We're asked to evaluate tangent of A plus B, and so if you have two angles being added together, we need the sum and difference identities. I've got them off to the side here. Some number plus some other number, you can rewrite it using this formula. Before we do that, let's draw tangent A equals 8 over 5. Oh, I guess we don't need that. No, we're good. Okay, so we're supposed to find tangent of A plus B. We already know what tangent A is, what tangent B is, so we can jump right to the sum formula. It's going to be tangent of A, which is 8 over 5, plus tangent of B, divided by 1 minus tangent of A, tangent of B. All you have to do is plug in the numbers. We have 8 over 5 for the tangent of A. We have 7 for the tangent of B. We've got 1 minus 8 over 5 times 7 in the denominator. So if we try to add these, I'm going to get common denominators. 7, that's 35 over 5. Oh man, I stayed up late last night watching the election results. 43, there we go. So we got 43 over 5. And then the bottom, 8 over 5 times 7, so 8 times 7 makes 56 over 5. Just doing fraction arithmetic, right? So this is 5 over 5 if I cancel out that 1. And so in the denominator we got 5 minus 56, that makes negative 51 over 5. And in the numerator we have 43 over 5. So this is division, right? So that's the same thing as saying 43 over 5 divided by negative 51 over 5. And so you can flip and multiply those fractions. So that makes negative 43 over 51. Look, if you add these up, 150 plus 45, that makes 195. We don't know, we don't have exact reference triangles for 195 degrees. We got them for 150 degrees, 45 for 30, those are all 60, those are all ones we've done before. But we don't have something for 195. What we can do is we can say this is our alpha and this is our beta, and we can plug that information into the formula. Once we find out what tangent of 150 is, once we find out what tangent of 45 is. Okay, so tangent of 150, we're going to evaluate that by drawing a 150 degree angle. Make our triangle with the terminal side. This is our reference angle, and it's 30 for the reference angle because it would make a semicircle if we were to go all the way around. We've only gone to 150, so it means there's 30 left for that semicircle. And so the 30 degree angle is something we can have memorized from a reference triangle. 1/2 is always opposite of 30 degrees, no matter where it is, and then square root of 3 over 2 can be opposite of 60, and 1 is the hypotenuse. So for this 150 degree angle here, this is 30 degrees, so this means this is 1/2. And that means this up here is going to be 60 degrees, so this is negative square root of 3 over 2. And I put a negative sign because we're going in the negative direction on the x-axis. And so now we have a triangle fully labeled, now we can do tangent. Tangent is the opposite divided by the adjacent. So if you flip and multiply, we're just going to put the negative sign up top out of a habit, that's negative 1 over the square root of 3 if we don't rationalize the denominator. So we now know what tangent of 150 is. It's negative 1 over the square root of 3. We can do the same thing for tangent of 45. You might already know the answer to this one, but tangent of 45, draw your reference triangle. The 45 triangles, they have square root of 2 over 2 for the non-hypotenuse sides. So the opposite, divided by the adjacent, is just 1. So that'll be nice. Okay. So this is like our alpha, this is like our beta. Let's plug them into this formula where we see them. It's going to be 150 we said was our alpha, and tangent, I'll just write it out the long way first. Tangent of 150 plus tangent of 45 over 1 minus tangent of 150 times tangent of 45. Okay, and we know tangent of 150, we said that's negative 1 over the square root of 3, which we'll have to clean up later. And we just evaluate tangent of 45, that's 1. And we have 1 minus the tangent of 150, that's negative 1 over the square root of 3. And then times tangent of 45 is 1. Oh, I'm running out of room. Often happens in this class. Alright, so we could get common denominators here. This is the square root of 3 over 3, right? So the numerator becomes negative 1 plus the, square root of 3 over square root of 3. This is the numerator of that top fraction. And then in the denominator, same type of thing. I'm going to change this to a plus because we're subtracting a negative. And so this is the square root of 3 over the square root of 3 plus 1. So square root of 3 plus 1 over the square root of 3 in the denominator. Big yucky fraction. It's right, but we just need to simplify a little bit. So I'll copy it over here to show you what I do next to simplify. Look, this is the division symbol, right? So I'm going to rewrite it as the square root of 3 plus 1 over the square root of 3. And then I can flip and multiply. And now these cross cancel. And that leaves us with negative 1 plus the square root of 3, because it's times 1 over here, over the square root of 3 plus 1. And I think that's as simple as we can go. So let me type that in Newton so we can get that right. Negative 1 plus square root of 3 over square root of 3 plus 1. So I'm going to make a fraction right off the back. We said negative 1 plus the square root of 3 over the square root of 3 plus 1. Okay, and then like that answer. Oh, so there is something we could have done to simplify. Let's see what they did. Square root of 3 plus 2. I mean, there's a lot of steps that they went from to get from here to here. Luckily, it accepted our answer. But I think, yeah, what you could do to simplify this further is you can multiply the top and the bottom by the conjugate of the denominator. Square root of 3 minus 1 over the square root of 3 minus 1. That would get rid of the radical in the denominator, and I think that would simplify a little bit more. But you know, once you get down to a fraction that you can type in, Newton should automatically accept it.